Hi everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 3 from chapter 7, which is talking about absolute value equations. So there are two ways that we can solve an absolute value equation. The first one is we can use algebra. And so to do this, we have to write something called a piecewise function, which I mentioned in our very first lesson. And that would be using that definition of the absolute value. Or you can graph the left side of your equation, graph the right side, and then look at their intersection points. Wherever the intersection point is or are, those would be your solutions to the equation. And with either one of these two methods, you should make sure to always verify your solutions. So in this video today, we're going to look at example number 1 from your notes. And this one here is going to look at a graphing situation. In the next video, I'm going to work with algebra and how to write a piecewise function. So here we're going to solve the equation. The absolute value of x minus 3 is equal to 7, and we're going to use graphing to do that. So what we're going to do is we're going to take this whole equation, we're going to split this into two parts. We're going to set our the left side of the equation equal to y. So we'll write y is equal to the absolute value of x minus 3. And we're also going to graph the right side, which is y is equal to 7. So what I need to do here is I'm going to graph the first equation, then I'll graph the second one, and then I'll find those intersection points. And so in order to graph our first equation here, we have y is equal to the absolute value of x minus 3. I first want to make sure I show that intersection point with the x-axis, or where your graph reflects from the negative x-axis to the positive x-axis. And that there is when it crosses that x-axis. So we're going to let y equal 0 and solve for x. And so, as I mentioned in previous videos, when we have anything that's equal to 0, some sort of absolute value function, if it's equal to 0, we can just drop these absolute value symbols, because all in all, whatever x value we should have should make it equal to 0, and the absolute value of 0 is just 0. So you have 0 is equal to x minus 3. We're going to solve for x, so we want to get rid of the subtract 3, so we're going to add 3 on each side. I'll just write this over here. So our x value here in this case is going to be positive 3. So that right there is where we're going to see that crossover from the negative x or negative y-axis to the positive y-axis. Sorry. So one other note is when I'm graphing, if I'm trying to show two different graphs, I'm trying to show their intersection points, I want to make sure that I can see that on my graph. So here we're at y is equal to 7. And if you guys remember back to grade 10, this type of graph is going to be a horizontal line. So it's going to be every point where y is equal to 7. So it's going to create some sort of horizontal line, something like this. And when we have the line y is equal to the absolute value of x minus 3, there's going to be some sort of V-shaped graph happening. So we want to make sure we can see this part of the intersection and this part of the intersection. Okay, so if we were to extend those lines, they would at some point intersect. So we need to make sure we show both of those intersections, which is also another reason why we also have this middle intersection where it reflects about the x-axis. So when we're choosing points, we want to make sure with our first equation that we can actually see either where it intersects exactly at 7 or where it goes beyond that, because then we can estimate that value. So we're going to start by putting in our vertex of that absolute value function. So that'll go right in the middle of our table values. And then I'm also going to choose 1 point above, 1 point below as well. And I'm not going to fill out the whole table just yet, because what happens if we chose really small values and we never actually got to see this intersection point? So I'm going to leave the first and last box or row until I kind of figure out what's happening with the graph right in here. So maybe just to start, I want to make sure I get up to 7. So I might start by going down 2 to positive 1, and I might go up 2 to positive 5. And those are just values that I chose, just because I know I need to get up to 7, so I might need to choose a little bit bigger values. So now what I'm going to do is I'm going to plug these values in and see what my y values will be, and that will help guide me for my other two rows here. So the first one here is when x is equal to 1. So you have the absolute value of 1 minus 3 is up. And your absolute value symbols which is equal to 1 minus 3 is the absolute value of negative 2. When we apply that absolute value, we get positive 2 as our answer. So here we're pretty small here. So we're at 2. But we need to get all the way up to y is equal to 7. One thing that's great though is that here we see the absolute value is getting used, which means that this part here is being reflected. So that just means that we might want to go a little bit more. So it means that we're probably somewhere over here. So you might want to go a bit bigger just to get back there. And then we can go from there. But we'll keep filling out the rest of our table of values first. So here we have x is equal to 3. So we have 3 minus 3, which is equal to 0. So the absolute value of 0 is 0. So the next value we're going to work with is when x is equal to 5. So we're going to put that into our equation. So you have the absolute value of 5 minus 3, which is equal to the absolute value of 2. The absolute value of 2 is simply just 2, and that there is our y value. So as you can see, we're working with some pretty small numbers here. We're not quite either at or above our y is equal to 7, so we want to keep going. So you can even look at the patterns of this graph. When we're going up and down by 2, that's what's happening. We're going up and down by 2. So maybe I want to try going up by, we want to get up to 7, so I might want to add 5 to my top value and subtract 5 from my bottom value, just because of the way that I'm looking at the trends here. You can also look at your equation. You can ask yourself, well, what value, if I added it, or if whatever I put in for x, if I subtracted 3, what would give me 7? So my first one could be 10, because 10 minus 3 is 7. And then we have to also have to work in our negative values. So negative 4 minus 3 would give you the absolute value of negative 7, which would come out to 7. So you can either use your logic or look at the pattern that's happening here. And so what we can do is try adding 5. So we would get 10 above, and then we go down to negative 4. So put each of those values into our equation. So we have the absolute value of negative 4 minus 3. Negative 4 minus 3 is equal to negative 7. And the absolute value of that is just positive 7. So here we're going to be looking at those intersection points, which is exactly what we wanted. So now looking at x equal to 10, we have the absolute value of 10 minus 3 is equal to the absolute value of 7. And that works out to 7. So now we're ready to start graphing. With y is equal to 7, you don't need to do a table of values for that, because we know that from grade 10 that it's either a horizontal line or it's every point where y is equal to 7. So you can just use that logic and don't have to worry about creating a table of values. So now we can look about working with our spacing. So we need to label our x and y axis. And so just worrying about the x-axis right now, our biggest value here is 10. So we want to make sure we can get all the way up to 10 on our axis. So if you count here, this is the same graph as what we've been working with this whole time. So we know it's from 0, or your origin, all the way up to the positive x-axis is 10 lines. So at this point, it's okay if you guys went up by every line is 1. But if you didn't see that intersection point, like say if this was a 6, you definitely want to go up a little bit by a higher scale, just to make sure you can see that intersection point. So in this case here, I'm okay if you guys go up by 1. But if you want to make sure you can show your intersection point maybe a little bit more in the middle of your graph, you might want to go up by 2s instead. But because we can see that intersection point, I'm okay with going up by just every line is 1. Once again, I'm only going to label every second one just to make sure I don't have a whole lot of clutter going on in my graph and make it look confusing. Then we can read about our y-axis spacing. So here our highest value there is 7. So I think we can do the same type of spacing for this graph as well. All right, and then just to reiterate, maybe if you didn't have such an easy to, I guess, visualize second equation like y is equal to 7, you might want to go up by a higher scale for your x-axis, just to make sure that you can fully see that intersection point. So now we can start graphing. And so I'm going to graph my first one here, and I'm going to do this one in one color with pen, and then I'll do my y is equal to 7 in a different color. So here our first value here is -4 and 7. So go to -4, go up to +7. Then I have 1 and 2. Then we have 3 and 0. So this one here is where our graph starts to reflect. It'll be going up in the positive direction. Then we have 5 and 2. Then we have 10 and 7. Then we can just connect those points. Make sure to use a ruler for this. Obviously, I can't use a ruler since I'm on a computer, but you guys can do that on your sheets of paper. And so that one there is my first graph. And whenever we're trying to graph multiple graphs on the same piece of graph paper, we should always make sure we label our equations. So in this case here, we had y was equal to the absolute value of x minus 3. So make sure you label it. Make sure you put arrows on the ends of each of your graphs there. So I'm going to graph the second equation there, which was y is equal to 7. So that one there is just a horizontal line. And once again, put your arrows on the end of each of your graph and make sure you label the equation. So that was y is equal to 7. So that's a horizontal line. So no matter what part of the graph you looked at, every y value, if you were to write down the coordinates, would give you 7. So that's how you can kind of remember that your y equals 7 type of equation would be equal to a horizontal line. So now that we have these two graphs already on the same graph, now what we can do is look at our intersection points. So I know mine looks a little bit sloppy here, but that's just because I didn't have a ruler, which you guys should for yours. But so what we have to do is we have to find those intersection points. I can tell from my table values where my intersection points were, but your graph should be very clear since you are able to use a ruler on your paper. So one thing here that's really important is that if I go back up to the equation here, we have x minus 3 in absolute values brackets is equal to 7. So notice how there's no y variable anywhere in this equation. So we want to make sure that when we're labeling or stating our solution, we're only giving the x value. So in this case here, our x value is -4 and x is equal to +10. So once when you found your solutions, I know that this question didn't ask you to verify, but please make sure you verify your solutions just to make sure that they actually do work. Unfortunately, I'm running out of time for this video to actually verify, but if you guys have any questions on that, just make sure, try it on your own, and then come see me in class. I can give you some pointers or let you know if you're in the right direction. So once when you've done that, you'll have fully completed this question, and you guys are ready to move on to the next example. So thank you guys so much for watching. If you guys have any questions, come see me inside of class, or you guys can text me on Remind 101.